In the last video, I thought I can compress all the Honeybee Create tools into one video, and it completely didn't work. It got way too long and I had to split it into videos. I hope you don't mind. We still need to cover some of the topics, some of the tools in Honeybee Create, but I think they are equally important. So let's not waste more time and let's jump in. Just very quickly, a recap. So we built this very simple but equally beautiful masterpiece of architecture with two boxes on the ground level, two boxes on the first level, and we applied apertures, also called windows. We applied shading, a door, and louvers. And I want to very quickly go through the different steps on what we took. So just to repeat, we fed basically these boxes, and they need to be closed, and I will talk about it a bit more. We fed these boxes into here, into this tool called Honeybee Intersect Solids. So that makes sure that rooms or surface or closed poly surfaces which touch get split at where they overlap. So to make sure that later on Honeybee understands what is an interior wall and what is an exterior wall. So basically in that case here, the smaller wall, and I made it deliberately not as tall as the other one. This tool basically recognizes that this room is touching that wall of the bigger volume in the back, and creates a subsurface on that wall, of the larger volume, and cuts out a surface. That makes sure that Honeybee knows, okay, there's two overlapping surfaces of the same size, and that is an interior wall. Otherwise, Honeybee would think it's an exterior wall, which is a big difference. So because we want to apply different parameters and attributes to the upper level, and then other attributes on the lower level, we split the two in two groups. So we have level 1 here and the ground level, and we also call it here level 1 and ground level. And we just use the list item tool to split these lists into two groups. There are probably other ways to do it. I use this method for this example. So why do we need to create a room? Like for example in Revit can apply information to geometry, and in a way Honeybee does something similar. It attaches information to a geometry. The geometry coming from Rhino is basically a dumb geometry. So for example, we can add a name, we can add program, we can tell Honeybee that these rooms are conditioned, we can tell Honeybee the roof angle, and so on. And that creates two boxes which have information attached. And then here we ran the solve adjacency tool, which basically makes sure that Honeybee understands what is interior and exterior. Just to remember that this tool just cuts basically subsurfaces into my geometry, but it doesn't tell Honeybee what is an interior and exterior wall. That tool does that. That will make sure that it understands, this box here has a surface which touches another surface from the other box, and has the same location, same size, and matches completely. And that gives Honeybee the information that this could be an interior wall or an air wall. Here actually we use the air boundary, which makes that surface basically disappear. It becomes a big room instead of like two rooms. So that's one thing we added. And we also added a skylight on this. So we split it up because we want to have different attributes on the level 1, and then another set of attributes for the lower level. That's why we split it in two groups. And then we basically, for the ground level, we run the same, but we don't have a skylight. That's why we don't have a skylight here. And of course we could apply a door here, which leads to the terrace and so on. But yeah, it's just an example. And then we need to run the adjacency tool again, so Honeybee knows from both sets on how they connect to each other. So now Honeybee knows that, okay, that surface here below that small box must be a floor, but it's not a ground floor, because it sits on top of the other one, so it can't be a ground floor, but it's a floor. And from the other side, it knows that this surface here inside is gonna be a ceiling. That's why we need to run it twice. So we ran it here once and then another time twice. And here we didn't use the air boundary. That means that this box here and that box here, they stay separate rooms, but with an interior wall in between. Just to show you that quickly, preview interior wall, and yeah, so you can see that. And here would be the air wall, which is a non-wall. There's no wall, and exterior walls. So after that, we apply all the apertures. We apply geometry for the windows and the main door, and shading and louvers. So we have also louvers on the windows. And this is just simple geometry. We just apply, for example, here for the shading. It doesn't have to be complicated because we try to simulate something. We try to create a model where we can measure things. So after that, we applied everything, and you always need to apply one by one. So we apply first the subsurfaces, which is the door and the apertures. That can be done in one step. So we basically feed the current rooms into this object here, add subsurfaces, and we add these two things here. So we have surfaces for that. The window surfaces need to be aligned. They need to touch the walls and also the door. And then the shades can be detached, but you need to decide if they are outside or inside, because that will have an influence on the energy calculation. And then we also did shading on, just to show the example, we also did a shading on the windows on the side. You can add it like this. And then we also added louvers, and we tested some different parameters. And then we just visualized it. So we put everything together in a model, not for all of the calculations in, for example, Honeybee radiance and Honeybee energy. You need that, but most of the time, Honeybee radiance, you will need a model in most of I think in pretty much all of the recipes, analysis recipes, you will need a model. But that's basically just a collection of rooms, and there could be other faces in there, and shades and apertures and doors and so on. And from there we do all our calculations. And first I just showed that there are ways to visualize, because the thing is, if you try to visualize it with let's say grasshopper standard materials and so on, it's going to be tricky, because this is not a typical mesh. It's now a different type of geometry. There is a geometry with data attached, and that's need to be, if we want to visualize it here in Rhino, need to be retranslated to something we can actually look at. In that case, that tool does it for us. It just visualizes the wireframe of that building. And then these basically feeds the object in, and every object, walls and so on, they are meshes, but they have more data attached, and we basically just extract the mesh from that data set to make it visible. And yeah, there are other ways to visualize stuff. You can visualize by attribute and so on. Okay, I want to quickly show you that there are other ways to build walls, build rooms, and we can go here, Honeybee. So we build the rooms by using solids. We can also use this tool, Honeybee Room, and this is basically you build your room with faces, with Honeybee faces. So for example, I have another box, explode that, and have 6 surfaces. I can here just use the geometry container, set these multiple surfaces here, and now I need faces, but I can't put this in here. That doesn't work, because that is not a Honeybee. These are not Honeybee faces, so these are dumb faces. Dumb faces. We need this tool here, Honeybee face. We already applying data to it. So we can put the geometry here and we can put it out here. And by the way, it works because it already knows, okay, we have a room, and the room has, because it's a closed, although these are like separate surfaces, it understands, okay, this is like a room because the edges are closed, and it's basically a closed box. But you could also create a very individual Honeybee geometry. Copy this, set this as one geometry, then it's just a face, it's not a room. That Honeybee, if I put this in here, Honeybee doesn't understand. It says, okay, it's a face, but it's not a volume. It needs to be a volume. And by the way, it doesn't work if you do something like this. If you want to feed something like that into Honeybee, and I can show you what happens if I do this and I use from solids, for example. So for example, I would feed this in here, then it thinks it's a room. But if you look at the visualization, then you realize that actually doesn't work. So if I go here and try to visualize this, then it's an exterior wall. It has a roof, which is the top face of the wall, and it has an exterior wall outside and the ground underneath. So it doesn't give you an error, but it's wrong. That could be tricky for somebody who starts with Honeybee, because they think, oh, they just put the model into here and that's it. It doesn't work like that. So again, yeah, this is a bit dangerous. So if I put this in here, that also doesn't work because it's not a room, and this tool doesn't understand what that face is. That maybe works if I would now add an attribute here and say this is a wall. You can specify the type. You have 4 different types you can specify here: walls, roof and ceilings, floor, and air boundary. Can put this here. I'm not sure if it works. Let's see. It seems like it works. So I can hide that. Yeah. So although it didn't create a room, it gives you the warning: input faces do not form a closed volume. Room volume must be closed to access most Honeybee features. Preview the output room to see the holes in your model. But it still goes through as a room. So it goes through as a room, and it will actually visualize here as a wall, because I set a name here and gave it wall as a attribute. That's why it's visible. I could also call this floor. Now it's actually shown as floor. So if I go here now, then it would show. It recognizes it as floor because I specified it as floor, but of course it's not a floor. Okay, what if your building just doesn't look like this? It looks like this. What if it has curves? And it took me actually a while to make that work. But yeah, you can also make a room out of this. You need to use this tool here. Planarize B-wraps. So this is just a loft, and then I just closed it with some flat pieces. I had to slightly adjust the curves because it didn't create a clean mesh. But I think as long as you can create a clean mesh, you can work with any shape. What happened with this one, it didn't calculate properly, and I had a hole actually in my surface. So I don't know exactly why, but now it works. So I tried a bit and it works with this shape. And what we need to do first is to put this in a B-wrap container and set one B-wrap. Yeah. So now we have this here, and what we need to do, because Honeybee need more like simple geometry in order to run calculations. That would be difficult, and basically you need to planarize or facet your round shapes or curves. And just put this in here, and you can see that it created a mesh object. I can hide this. So this is my object now. Disable here, and I'm gonna turn this off. Also hide this. And now I can put this into my room. Or like I can create a room, a Honeybee room out of it. And I can use the Honeybee from solids because this is a solid object. And you can already see it takes longer to calculate. And now we can visualize it. Just copy this here. And here is my room. And same, it recognizes that all these faces here are the exterior wall. And of course now these are many walls, small walls. And then we have the roof and the floor. And then of course you could attach or create subsurfaces, which then are windows or doors and so on. So Honeybee does not just work with boxes. Much simpler shapes could be also like a sphere that also works. And as you see here, actually, from a certain angle, it then assumes that these faces are the roof. The funny thing is now, if I attach skylights to the roof, then it's all gonna be a bit weird. But yeah, I could do this. I can set the ratio. Now I have skylights here. Yes, so now let's very quickly cover some of these objects. You wonder probably, and I actually didn't really had a use for this, but recently I actually realized that these are very important. So if you want to if you want to rotate your model, for example, remember that you can't use, because it is a Honeybee model. It is a Honeybee model. So it's now if I do this, so this is my Honeybee model now, and if I want to rotate that, I can't use a normal rotate function. So if I would use, for example, rotate this, it doesn't know what kind of geometry that is. And for example, if I want to test an object from different rotation to the sun, then it's important that I can rotate it. And that's why we have these tools here where you can translate your model. Mirror, you can move it, you can rotate it and scale it. So it stays a Honeybee model. In that case, I would do it like I would run it before I put everything together in one Honeybee model. I would rotate all the objects, and you can just apply a slider here, and it's going to be an angle between 0 and 360. I can add this here, and now I can rotate my model. Now this is of course very heavy geometry, but I could apply this here also. Now, problem is that everything rotates around its own axis. Then we need to provide, of course, an origin where everything can rotate around that origin. It can be, of course, somewhere else. It doesn't have to. Can be in the middle of the. So now it should work. So if we have this, now it works. Yes. So we need to provide an origin in order to. I think that's it. There's a bit more, but this I think we can go through when we need it for other models or for bigger models, because we are already there, and I don't want to waste your time any longer with this first bit here. And we can go for some of the items a bit more into in detail, but I mean, we touched a bit on how to visualize. There are other ways to visualize, and there are other ways to separate things. Yes, there is kind of this tool where you can deconstruct a model again. So you can go in here and extract all the faces. Actually here, because this is the model, the model is created from rooms, so it actually just divides everything in rooms again, and you can do separate studies with individual rooms, for example. So, but you can also visualize. So we visualize by type. There's another way, visualize by boundary condition. So we could, if we close this here, you can see outdoors, pretty much everything. Surface, I guess it meant indoor. So there are more ways to look at the model. There is another one Another way to organize your model. This is not for visualization, but for extracting certain types by using attributes. For example, I could extract from one model, let's say, and here you need to apply an attribute. So this is here it's called face. Separate and group Honeybee faces, apertures, doors, and shades by any attribute that the object possesses. So you can use the attribute, the face attribute tool here, list select. It gives you a list of ground level has that amount of faces, and also shows you how many Honeybee objects. And then you can basically select. You can also do the same with rooms, and there is this tool here with the room attribute where we can select by certain attributes, like for example volume. You can see the values of the volume, for example, the room values, the volume of each room. And I guess it would, if I would now have two rooms with the same value, then they would be a group. I can imagine that how that works. And then these are very interesting. You can actually translate your object into a JSON text file. Put this here. It actually creates. It becomes very slow, by the way. Basically, describes the whole model in this text file. So you could, in theory, store this text file somewhere. And I show you that this works. Is now you can also load a text file. So if I do this, computer slows down completely. But if I now reload the text file into an object, then you can see already, okay, 4 local defined values, room level 1, ground level 1, ground level 2, room level 1, 1, and level 1, 2. And now I could feed this back in and you will not see any difference because it was just stored as a text file and then basically reload. In theory, you could take that and store it as a text file. So here, basically, it automates that for you. You can dump this in a folder. It will define a folder, and with dump, it will just write your model as a JSON file into that folder. And then, so it's basically you just, instead of like run it, you don't run it, you dump it. And here you can just provide the address of your folder. And with that, you can then reload that model. It's pretty cool. So you can actually store models like that in that way. Here that also allows to compress the models or the objects. And here you just have different file options to store your model. So I'm super happy that we finalized that chapter, Honeybee Create and all Honeybee core elements. And so we can move on to Honeybee Energy and Honeybee Radiance. Now with the model in place, it's going to be much easier to understand all the rest. You need to understand the model first in order to get a better grip over these things. Radiance is a bit more easier to grasp, I feel, and Honeybee Energy is a bit tougher. But I'm very optimistic that we can make it and understand. Anyway, see you next time, and let me know if any question, any comments, if you think I should change something. Always up for new ideas. Please let me know. I am very busy at the moment, so I might not be always able to bring out these videos on a weekly basis. I hope I can do it still. See you next time.